afternoon to everybody. My name is Linda Caccia and I'm very happy to meet you, even if just virtually. But I hope to meet you actually very soon. I'm a teacher of mathematics and physics and I've worked at Liceo Socio-Psicopedagogico in Giarre, Michele Amari, since September 2007. One of our classes is 4th H, which we carried out our Physics-English Clil project with. In our 30-hour Physics-English course, we mainly worked at physics laboratory, using its equipment to prepare easy experiments, which our students already showed during the last physics exhibit at High School Leonardo in Giarre last week. Now it's my colleague's turn.
Good afternoon, I'm Elvira Sorbello, the English teacher. I'd like to present you our project in a few sentences. We started by introducing the most relevant laws and topics of mechanics with the help of the whiteboard. Our students were requested to take notes, ask questions, search and learn new vocabulary, summarize and make reports. After the theoric section, they were asked to put in action what they had learned by doing the experiments with the use of the scientific equipment in the physics lab. Finally, the students performed again the experiments, explaining them using the scientific specific language they had memorized in the previous activities.
We wish to conclude our project thanking our students for their enthusiastic participation to the project. Thank you very much to all.
Hello, my name is Adalgisa. Hi, I'm Jessica.
Hi, my name is Sara.
Hello, my name is Juicy. We show you Newton's tube experiment. Newton's tube. In absence of friction, any object falls down under the action of gravitational acceleration at the same time and with the same velocity, independently of its mass.
We want to demonstrate it with this tube inside which we make the vacuum through a vacuum machine. Newton's tube is composed by glass tube inside which we put three objects with different masses: a feather, a metal dish and a cork dish.
When inside the tube there is the air, its resistance acts on the objects and they fall down with different velocity. But if we make the vacuum inside the tube, we observe that the objects fall down with the same velocity and they reach the bottom of the tube at the same time. Aristotle thought that the falling off the object was due to their weight. This idea was wrong even if we observed it in nature. With the Leaning Tower experiment, Galileo demonstrated that any object falls down and reaches the ground at the same time independently of its mass.
Hi, my name is Valentina.
Hi, I am Veronica.
Hello, my name is Luciano.
Hello, hi Martina. We will show you the electrostatic stick experiment.
Some materials such as amber attract lightweight particles after rubbing. The Greek word for amber electron was the source of the word electricity. Electrostatic phenomena arise from the force that electric charge, either positive or negative, exert on each other. Electric forces in nature come in two kinds. There is an electric repulsion between the same charges, both positive or both negative, and the electric attraction between opposite charges.
The electrostatic stick experiment is based on this physics phenomena. Inside the stick there is a little machine producing a lot of electric charges to rubber.
These charges are transferred on the surface of the stick. So when we put on it lightweight strips of thin mylar, they seem to fly because they are repelled by the same electric charges.
Hello, my name is Chiara.
Hi, I am Elisa.
Hello, I am Miriam.
Hi to everybody, I'm Martina. We will show you the double cone experiment.
This experiment is called double cone paradox because it shows a strange effect that seems to be contrary both to the common sense and to the physical law of gravitational falling. It is composed by an inclined plane and an object which is made up of two cones united by their bases. When we leave the double cone on inclined plane, we notice that the double cone goes up along the plane. But it's impossible. Is there any object that violates the universal gravitational law? Certainly not.
Now we try to give you a scientific explanation. The effect that we notice is just an apparent effect because the starting point of the double cone is higher than the right
So,
cone.
according to the most rigorous observation of the gravity force, the center of gravity of the double cone falls downwards and its upwards motion is just an apparent division to the shape of the object.
Hi, I am Andrea.
Hello, my name is Giulia.
Hello to everybody, I'm Lisa. Hi, my name is Manuela. We will introduce you the first law experiment.
Newton's first law says that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction until an unbalanced force acts.
We wanted to demonstrate it with this machine called the inertia machine. The inertia machine is composed by a wooden table, a wooden support, a metal ball, and a thin metal table.
If we remove quickly the thin table, the ball stays in initial position. In fact, the ball remains on the wooden support.
In this way, we verify that an object keeps on doing what it's doing.
Hi, I am Maria Chiara.
Hi, I am Eva.
Hi, my name is Sandro. We will show you the magnetic field experiment. People not familiar with magnetism often view it as a somewhat mysterious property, especially treated iron or steel. A magnetized bar has its power concentrated at the two ends.
The north end will repel the north end of another magnet, south will repel south, while north and south attract each other. The region where this is observed is called a magnetic field.
A magnetic field is represented by lines of force called magnetic field lines. Field lines of a bar magnet are commonly illustrated by iron filings, sprinkled of a sheet paper held over the magnet.